Welcome back, Generals, to another Let's Fix Generals 0 hour to make the best game ever. Okay, so we got a bunch of questions here in the video comments, so let's go through this. So Mr. FYP is asking, I've seen these projects and I got a questions. Could the prisoner of war logic system be added this way? There are currently no plans to add prisoner of war logic because it's not part of the original game. So if this is added, then this would be added like to just enable it for mods to use and not to add it to the core gameplay loop, right? So I know that there are traces of this in the INI, and there are also models, like there's a USA POV truck and like model, and there are also some voice lines for prisoner of war, but yeah, it's not part of the original game, so it's not something we focus on, right? So there's a question about, we need a recap of Thyme and Super Patch, what state they're in, and someone else is also asking for this. Okay, so recap. I mean, so last couple of months there wasn't so much progress towards Thyme and Super Patch, I would say. The main problem is there are not many people working on this actively. Right now it's mainly myself driving progress, but also only like tooling, right? So unassemblize is just a tool to facilitate progress towards Thyme, right? But it's not advancing Thyme itself. So the complication is you first need to build an ecosystem of tools to actually get there to build what you want to build, right? It's not like you snap a finger and everything is done and easy peasy, but like we don't even have tools to build the things we want to build, right? So the things are tough out there, right? So Thyme, Thyme is this one here on the GitHub, right? It's still at 52% complete with an asterisk, complete, aka somewhat working. Well, it is working. We can run it and see for ourselves. So if we run this, it will compile. Okay. Are we on some unfortunate branch? Let me see. It will start the W3D viewer. Hold on. Let me launch here. We are on the develop branch. Okay, so that's good. So Thyme is 52% complete, and with that we don't know the quality of those 52%. Like there are probably still bugs that are very Thyme specific, which need to be fixed, and this is where unassemblize will help us to get there. But the problem is, Thyme right now is written not 100% one-to-one to the original. So some symbols are not sharing the same name, for example. So the functions are not 100% the same, don't have the same naming conventions. This was one mistake when the project was started. And different names were chosen. So there is a new effort, Thyme NG. I don't know what NG stands for. This one aims to have a one-to-one copy with all names 100% equal, and the compiler the same as the original Windows compiler used for the original game, to then have like a one-to-one exact match to the original executable. So for this, my expectation is that in the next months that we will copy code from Thyme to Thyme NG, but with one-to-one copy in mind, so that we really get a one-to-one copy that is functionally 100% identical to the original. That must be the goal. We must reach the state where all code in Thyme is 100% original, 100% identical to the original, right? So that the game runs the exact same with all the bugs as is with the original one, right? And then we can start fixing the bugs, right? And improving things and improving performance and so on, right? So that's a goal. Still a long road ahead. My immediate plan is to like wrap up for now and unassemblize, because that on its own looks pretty okay already. It looks pretty usable to do what we want to do. And next step will be we need to generate C++ code from the Macintosh binary of 0, because that one contains symbols, aka function names, file names, and strings, and all sorts of things. It's not like a whole symbol. It doesn't contain all the symbols that we need, but enough to to understand what things are, right? And from this, we should be able to generate some C++ skeleton code, which will serve as a definite base that we can then add to Thyme and G, and then we can add on top of this. That's a hope. We still need to see how easy that will be. But yeah, that will be the next goal. Yeah, so Thyme development, the problem is right now, all of the reverse engineer guys, so those are Omniblade, Johnville, and Thompson's 26. These three people, they are the core contributors of Thyme. They are very busy with other projects. So Omniblade is, I don't know, busy with what? Johnville is busy with something he cannot talk about. Thompson's is busy with Tiberian Sun. So yeah, people are busy building other things. And so this project is not advancing, but ideally it would. Right. Okay, but still, we're making some progress, so there is some progress. Yeah. Game patch, same story. Well, core contributors are myself and Come2. Come2 is, I don't know, is gone. So right now it's mostly DM Green working on some language fixes, and Dev Genius Codes. That's an interesting name. Was working on some window thingies, but yeah, it's there's still so much to do. So the problem is the complexity of both projects is astronomical. Like Thyme is complex because the work, like to get the result, is so hard. Like reverse engineering is the hardest part of this thing. Like trying to make sense of the assembler code and writing source code from it is hard. It's really hard. It requires a lot of knowledge and discipline and awareness. Well, with unassemblize, we hope that we will make this the verification of what we write easy. So at least from this angle, it hopefully helps us going forward. Yeah, we still need to see it in practice, but so far things already look promising. So Thyme, we need reverse engineers to continue driving this. My hope is that once unassemblize is well advanced and the other tool to generate the C++ code is done, that I will help start porting the code from Thyme to Thyme and G to at least get it to the same progress as this, and verify that all code is 100% identical to the original. I think this I should be able to do. It just requires a lot of time spent to get there. But I should be able to do this. And once this is done, then maybe I should start learning like really good reverse engineering like Johnville does, because I'm not really into this yet. right? Okay, and then yeah, General's game page. I mean, there's still a lot of stuff to do um, with fixing any. I mean, we have 550 open issues, right? Lots of these are minor, right? Like some small things. A lot of these are executable, which is for Thyme to fix, right? So I think like 200 of these are executable, right? So you can already remove a lot. But yeah, there's still a lot of stuff to do in ini files. A lot of stuff to fix for AI. I think for AI we actually didn't fix anything yet. We still need a lot of tooling actually. We need tools for the models W3D to plain text. We need that. We need a tool to convert SCB, that's the AI script files, to plain text. Otherwise, it's impossible to properly fix this up. Like you can't use the native editors and binary files. It's madness. So we still need a lot of tooling actually to do what we want to do. The good thing is we have progressed well. Any fixing, like a lot of stuff has been fixed. So game overall is more stable and is probably running better with less glitches and less bugs than the original already. So that's good. The audio is polished. Textures have been polished a lot already. What else? Languages have been fixed up a lot. Yeah, but there's still a lot of areas that need fixing, like Windows menus need fixing. The AI scripts need fixing. The models need fixing. Yeah, there's still a lot to do. But I think the focus probably should be on Thyme for now, because that's by far the most important, because that's also the foundation for game page essentially in the end, right? Because a lot of fixes and functionality that we want to have in the game page needs to be facilitated by Thyme first, right? So it would be great to get this done, and then we can integrate it into game page, like combine these two projects, so that we can actually fix everything, fix game code, fix game data, right? Then you have the full package, fix everything, right? So yeah. Yeah, I mean, both projects are, you can run. So Thyme you can run by running the, where is it? Is it here? Let me see. Yeah, debugging, you just set here command run game dot, command argument -win, working directory 0-hour directory. Then we set this at the start project. We compile. It compiles. I don't know why it takes so long now. We compiled already before. Okay, then we need to go to configuration manager and enable install. So it actually copies the DLL files into the game folder, and then we press F5 and then it launches the game with Thyme. There we go. Yeah, that's it. Now you can't hear the audio because I've muted it in the recording, but the audio is running. We can open menu, we can maybe start a campaign, solo play, GLA, easy, which will load the mission, which will play a cutscene. As you can see, things in general work. Yeah. And it looks exactly like the original. Plus minus some bugs. Yeah. Yeah, so as you can see, Thyme is playable, it works, it runs, but yeah, it's not complete, and that is a problem, right? Things still need to be done. But it runs, so in principle, things are okay. Yeah, so I would say 52% complete is still accurate. Yeah. Okay, so that is Thyme. And we can exit the mission. And exit the game. And there's a crash on quit, which is probably Thyme specific. Let's see. Yeah, camera shake system. It's probably some bug on our side. Yeah. Okay. And yeah, game page, the same thing. Can be launched, can be played, and doesn't have any known bugs as far as I'm aware, right? So typically things are being tested before they are submitted to mainline, and things should work. Let's see. There we go. We can load a skirmish level here, test all factions, units promo here, put a USA guy here. There we go, play. And as you can see, units are here, things are working. Yeah, select here some units, attack the enemy. Very good, right? So yeah, I mean both projects are usable. They are not yet combined. There's still a lot of work to do, and the work can only get done if people are working on it, right? So people ask like when things are done, but I think that's the wrong question to ask. The question should be, what do I need to do to fix this or to do that, right? Or where should I go? Where should I look? I don't know. But at the end of the day, all the projects, both projects, all tools, everything is all public, so anyone can can pick it up and fix it. Like it's no one owns this, right? It's all, everyone can go ahead and fix these things, right? It is humanly possible, so anyone can do it. Yeah, it just needs, the problem is it takes time. Like you need to spend a lot of time fixing these things. Yeah. So, yeah. For now, I will just keep on working. I will just keep on working on whatever I can work on. I mean, it just takes, like, the problem is, like, when I work on tools, I'm not really progressing the core projects, right? And there's a lot of tools that need to be worked on. So as long as I'm the one who mainly works on these things right now, then things will just progress very slowly. It doesn't mean that there's no progress, but there's no big progress that makes big headlines. Things just advance very slowly. Yeah. But yeah, I think in the end, I mean, I'm not too concerned about slow progress, because as long as you make progress, you move ahead, right? So I'm not really, personally, I'm not concerned about it. If it takes 10 years, 20 years, 30 years, it's fine. So the only dead end for me would be when I'm dead. So, right? So it doesn't matter much. Like, I just keep on doing as long as I can, and then see how far it can get, right? But yeah, the work needs to be done one way or another. I want to be diligent with the work. I don't want to take shortcuts. So I rather do it thoroughly, like spend all the time necessary to do the things in the right way and correctly. There probably will be mistakes made along the way, but everything can be corrected. That's a good thing, as long as the projects are well maintained. You can always, like, find the things and make the corrections. That's why we are also so diligent with documenting all the changes we make. Like in the super patch, we have documented everything down to the last bone. Like everything we touched is documented in code. So like everything we did, we know exactly what we did, because there's a log for everything. Every value change is documented. So this makes me actually very confident that the project is well maintainable going forward. Like as long as we document everything, there's always a reference to look up, okay, what has changed towards the status quo. And the status quo is essentially law, right? The original is law. That's a baseline. So if we deviate from that, then that deviation better be for good reason, right? So there needs to be a reason why we deviate from the original, either because we fix a tangible bug, or we improve something that is not so nice, or we change something for reason X, Y, Z that makes game better in ways, right? So that essentially is the story. Yeah. Yeah, I mean, in the end, ideally, we'll have a product that polishes game codes, polishes game data, all the big bugs, all the small bugs, everything is fixed. All all the game graphics are polished. Everything looks nice. Yeah, that essentially is the goal. The goal is not so much as adding like tons of new features and factions and super things. No, it's just like preserving the original, but also making it better, right? Yeah. And of course, bringing it to other platforms, like having it run on Mac and Linux and whatever, Game Boy, yeah, will make a game more accessible. Adding new languages also will help with the accessibility. Yeah. Yeah, and of course a server would be nice. New server that works properly, so that you don't need Game Ranger, you don't need Redman, you don't need CNC Online. Just have one central server that hosts all games. Yeah. Yeah. So from my perspective, as long as it's just 1-2 people working on things, development can take really long time, because essentially there is so much to do that it would take a lot of time. Every time you add one more developer who puts as much work as I do, you essentially halve the development time, right? So you add one more, then development time is cut in half. You add another one, development time is cut to 33%, 25%, and so on, right? So if you find people who can sink a lot of time, then this would help driving progress. But it's hard to find these people because the modding community for this game is very small. Most people, they just want to work on like tiny things here and there, some map maybe. Like scopes are typically small because everyone has a given amount of time and he wants to get something done, release it, be done with it, move to the next thing, right? Typically projects are not built to last for decades, right? Projects, like most people work more short term, right? Whereas Thyme and Super Patch, they are more long term projects that aim to build something at a larger scale. It's like the most, I would say, biggest complexity. Now there are other big projects like Shockwave and Contra Mod and all these things. They're also very big projects, but yeah, these are like mods that like change a lot of things of the core game, right? This is not our goal. We don't want to create a new mod that adds new factions and models and all sorts of things that are not part of the core game experience, right? Yeah. If we add new things like the Prisoner of War, then this should only be optional content that someone can enable in a world builder or in a mod as optional content, but it shouldn't be part of the core experience, right? Yeah. There's nothing else I can say. I mean, we have to do better. We have to do more. I would just keep on working. That's all I can do, really. Yeah. Is it is it financially smart on my part to work on this? Not really. I essentially will sink years of my life into this, but I won't be able to generate any revenue from this. So essentially, this is just passion work, community work, for no return. It probably would be smarter if I would work on like an indie game to actually sell it on Steam and make money. That would be the smarter way. But I like 0 Hour, so I actually enjoy working on it and fixing it up. That's the only reason I do it. I just enjoy working on this game. That's it. If I wouldn't enjoy it, then I would probably work on some indie game, because there I would have like control over what I can do, and yeah, I wouldn't need to abide to the laws of an existing game. I would just do my own thing, right? Yeah. Yeah, I think in the end it would be great to have a game that is stable, polished. It would be great if then 0 Hour could become a more competitive game. Because right now, I mean, we do have nice tournaments with big prize monies and stuff, and there's some good presentation on YouTube and Twitch for this game, but it's nowhere near the levels of what it could be if the game was just super stable and high performant and really well polished. Then I think this would go much further. By the way, I don't hear the... No, I do hear. Yeah. Yeah, the game needs more polishing, and then I think it can attract more players eventually. Even though it's still it's a very old game, but it's a good game, all right? The core ideas are good. It's just so buggy. It's just so really buggy, this game, right? Yeah. By the way, in case you didn't notice, maybe you see it. This tank looks a bit different than the original. Here, the chain guns, they are not black anymore. They're actually gray now, metallic gray, which I think looks good. Also, the quad cannon now shows the muzzle flashes when it shoots. In the original, it does not. Now it does. Isn't that pretty? Yeah. We need to fix more. We need to polish more. Yeah. There's just so much wrong with this game. Changelog is already pretty huge. But there's still so much left to do. But yeah, the most important thing is that we get Thyme into to 100% complete, so that we have an exact replica of the original game code, and then we can add much needed fixes and improvements, and then I would also like to focus more on super patch to fix up things. But yeah, it's all the projects need attention. It's not just one thing that needs fixing, it's all the things that need fixing. And and I think it's fine to take the path of least resistance. Work on things that can be worked on. Get comfortable working on things. Because work needs to be done anyway, right? So if we fix it now or fix it later, it doesn't matter. The order doesn't matter so much as long as we fix towards the end goal. Yeah. Okay, anyway, I think that's enough talking about this. Okay. All right, so there was 35 minutes of just rambling. Okay, I want to go back to unassemblize. And I want to so last video session I looked into multi-threading for the work queue, and I was not happy with this code here because A, it's super complicated now, and B, it's a busy wait. This stuff is busy waiting here, this one. Which is not nice. The question is, what can we do here? Maybe we shouldn't have multi-threading for the work queue. I don't know. Can we salvage this somehow? Commands. Okay, how about... So this compiles. Let's make a copy of this. Okay, how can we simplify this? Essentially, we need to make it in a way where we don't do this here. Wait for. Futures. What would help here if we could enqueue in here, maybe. But but then we are racing, I think. Single consumer, single producer. Yeah. could have a lock here. Callback Q lock or polling Q lock. Yeah, we could lock these. Callback Q and Q. It's only enqueued here and here only here. So we could have a lock. Could have a lock here. Yeah. But that wouldn't help us much because the futures. Yeah. Do we need futures at all then? Um. So so maybe maybe we say here so maybe we put these guys in here. Then we do this. Then we do command has callback or this here. Then we don't do futures. We call detach task. So it doesn't create a future. And so at the end, it will enqueue here. But then we need a lock. So I think unique lock. Hold on. What did we use for? What did we use for? Client here. Shared mutex, mutex. Shared mutex. Yeah. Include mutex. Tomato. Polling mutex. Then we do callback mutex. Then we do SCD. I think unique lock. Lock. Lock, 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 unique lock. Lock both unique locks without deadlock. Huh. Interesting. Okay, unique lock. Lock. Polling mutex. Maybe it does make sense to pass at this pointer here. Callback mutex. Must take lock. Must lock here because multiple threads can enqueue here. Okay. Huh. Wrapper. Okay, so I think this might work as well. And then the advantage would be that we don't need this anymore, if I'm not mistaken. And this, and instead, Then here we also need to say do we have some here get task running. Get tasks running equals 0. And callback.size approx equals 0. One queue is empty. No running tasks are left. Quit. We do the same here. No. Let me see. Can we get rid of this condition? If it's not quit, wait DQ. Wait DQ. Yeah. I think we can get rid of this now. Yeah. Okay. Okay, then let's remove this. Let's remove this comment. Okay, so it's already much simpler. That's good. And I think this would work. What about this one? Can we simplify this? Quit. If quit, then try DQ command. If not, try DQ. Oh. Not try DQ. Wait, DQ. Right. Not try DQ. Okay, but so the advantage on the regular pass when it's not quitting, now we can again go into this waiting state where the thread can sleep. And so we don't have futures anymore. Don't have futures. Instead, the callback is being filled right at the end of the task. Right, so it does work here. And we have this stupid wrapper thingy. Yeah. NQ. Okay, but I think this is a better approach. We do have a lock, but the code is much simpler. We have no busy waits. And this one is probably not contended much, if at all. Yeah, this will be very rare contended. I think it's fine. Okay. Can we simplify this further here? If how was it before? Before we just had a break here. Continue. I think we can remove this comments. Okay, so get tasks running equals 0. Right, so there's no left, and callback queue is also empty. Callback has delayed. And queue. I'm not sure if this is a safe call, since we now enqueue on different threads. Like this call is no longer on the producer threads. Before it was, when this was still within this function. But now it's in the lambda, which is called on another thread. So this one, yeah, it's not here, it's not there. I would like to have this more elegantly here. I don't like this here. Can we remove this? What is up here? Oh. Right, we no longer return a result here. Yeah, I'm suspicious of this thing here. Hmm. 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 Callback queue. Size. Hmm. Hmm. Size approximate number of items. Hmm. Hmm. So, so if we have 0 tasks running, it could mean that we still have some for hello. Software is being buggy again, of course. There we go. Why is it going to update when I click on this function? That makes no sense. Man. What we could say is that if there are callbacks, We just discard the callback queue. Maybe. So the problem I see here is that when we quit and there are still tasks running, and one of these tasks push something into the callback queue, and then no more tasks are running, then it would succeed here and it would break, but then something would be in the callback queue if we wouldn't check here. But even if we check here, it's still not 100% because it could be that the main update then goes in here, already dequeues it. This one, so we're just in between here. It checks this. We dequeue. This is empty. This breaks out, but then it enqueues on the main thread here. And what we already broken out here, that could happen. So either way, this is not safe to call here. I don't know. I don't know how to gracefully shut this construct down. This update callback is a problem here in combination with this. Yeah. We would need to maybe we need to have a counter somewhere. Counter. A counter. And in theory, it would be safe to shut down here without considering what is left in the callback queue, right? Because then if something is enqueuing here, but we shut down anyway, then yeah, it will safely shut down without crashing, but it means that there's still some pending tasks that wants to be worked on in the queue here in this command queue, but it won't be worked on essentially. It's just discarded essentially. Yeah. If not, try DQ. Get tasks running. So I think this check is fair. Yeah. Yeah. Multi-threading is hard. Yeah, absolutely is. Um, it would be nice if the shutdown would wait for all commands and all delayed commands to finish. But for this, it would need the knowledge that this is all done here. Maybe what we can do is we can add a, let me see, a std atomic integer, and we call it m cute command count 0, yeah. And essentially, whenever we yeah, so if we go to NQ here, no, NQ, so this one is, what is this one calling? It's calling this one. This is private. Yes. So what if we here have NQ get command count, get commands Oh, it's complicated. I don't like this. Can we... Yeah, we would have to somehow say that we still have X amount of queues to commands to work on. But I don't know, it's too complicated. Makes the whole logic complicated and possibly error prone in some other regards, so that's not good. No. Can we... I mean, we could just say, okay, if we lose some commands, then so be it, right? Could just accept that. But it would be nice if we could guarantee that the whole queue is being worked off before we quit. So all the work, all the scheduled work is being done. Yeah, I don't know. It's just delete. Maybe. think I'm so close, but there's just this one problem. It's not easy to solve. Yeah. I don't know how to do it gracefully. It's since there's this update callbacks function which needs to be called on the main thread. This thread doesn't have vast knowledge about when it's ready to quit. This is straightforward. I think this is also okay. But this here is a problem. Because this racing here with this one, with this logic here. This can be empty and can still pending here and queue. So this thing is just racing with this thing here. I don't know what to say. Maybe we have to just abort the whole thing. Don't try to DQ. Just wait for the task, or cancel the task even. If that's a thing. Purge. Purge all the tasks. So we could purge the tasks. Purge. Wow. Get task total. Maybe we need to put a std atomic int. We put a callback queue size 0, and then here we put callback queue size plus plus, and here at the bottom we put minus minus callback queue size, and then here we say if callback queue size equals 0, and then here we make another check for try DQ. If not try DQ, then we are done. Okay, so first we check if we can DQ. something. If not, it will check if the total tasks in the work queue are 0 and also the callback queue size is 0. If that is the case, it will check once more if there's nothing in the command queue, because it could have been enqueued here before this one was set to 0, right? So it will try it once more, and if that's not the case, then we are really done. This might be robust. Maybe. Maybe. Let's add a comment here. Check the command queue once more, just in case another command was pushed, was enqueued in after the previous tests completed. Previous checks. Okay, so if it goes into quit, it will check if it try dequeue. So the queue is empty. Then it checks if we have no more tasks left, no queue tasks, no running tasks, 0. Then it checks if the callback queue size is 0 as well. It's an atomic integer, so that should be safe. And then it will check once more if the command queue really is empty, because it could have been filled here before this was set to 0, right? So it could have, like in between here, in between this line and this line, the command queue could have been filled when checking this, right? That's why we need to check it here again, right? Yeah. And if we dequeue another command here, then the whole thing starts new. Then it goes down here, and it will put something in the queue again, and blah, blah, blah. And then it will try to quit again until this condition is satisfied. Let's put a breakpoint in here. Let's put a breakpoint in here as well. Okay, to me this looks to me this looks that this should work correctly now. Let's try this. Okay, so wait, before we test it, let's double check this here once more. So callback queue. Okay, so here we enqueue, so we increment. Here we dequeue. We dequeue after we have incremented. How about we increment before we enqueue? Yeah. like this. Okay, let's see. Okay, let's first check if things work in principle. Compare. Okay, that was relatively slow. We are in debug. Okay. Okay, let's make some selections here. Okay, so it does its thing. Yeah. Async commands are pretty fast. Yeah. Okay, then let's run here long command, and then we do file exit. Yeah. Okay, file exits. Let's see what happens. Oh. Huh. Okay. No, that is unexpected, isn't it? What happened? Huh. So it looks like the main thread is deadlocking now, somehow. No, that's not good. Let's do it again. Exit. Okay, that has quit now. But we... Why did it not hit those breakpoints here? That I don't understand. It should have hit it. Let's put a breakpoint in here. Oh, that's curious. Let's do it again. Huh? Why are we not hitting any breakpoints in here? Okay, now this one has deadlocked again, the thread pool. Oh boy. Oh boy. Let's do it again. Okay, so this is hitting. Okay. Can shut down. Let's see. Compare, exit. Why is this now hitting so fast? Prepare, shut down, wait. Stop. Wait. Prepare, shut down, no wait. Where's this happening? Why is this? Why can I not see where this is called? Hello. Jesus Christ. Exit. Oh, we'll wait for all work to finish and then shut down the app. But it says no wait. Huh? Huh? Stop. Stop. Wait. Detach. Oh. Could it be that is busy? Maybe this is joinable thingy is not the right way to check if it is busy. Maybe we should check like a... Because if we detach, then it's not joinable anymore, right? mthread joinable. Stop. Wait. Enqueue. Is busy. Okay, so here let's put a not is busy. Okay, how about std threads? No, std mute atomic bool threads or busy false. And then we do busy true. And here we do busy equals false. Maybe volatile bool is enough here. Let's put it here, busy. Now we say I'm busy. Maybe we say am thread joinable or busy. Let's see. Okay, select this. Compare, file, exit. All right. Quit. Okay. This time we hit here. That's good. So it has nothing in the command queue. The tasks are not empty. We still have tasks running. So this will continue. This is correct. Yeah. And it will just keep on checking this. Yeah. Then let's put a breakpoint in here. So we need to wait a bit until this is done. And now all the tasks are done. The callback queue is 0. And this is also empty. And now it can break. And now busy is false. And now it should hit here now. In here, yeah. There we go. Okay, now it should be able to gracefully shut down. Hopefully without any stalls, and that worked. Okay, let's do it again. Breakpoints. Move all the breakpoints. Okay, and the help also says graceful shutdown finishes all tasks before exiting. Yeah. Whereas this one here will finish. What does this one do? Let me see. I think this will also wait. Compare. And when we click here, the UI has quit, but the program is still running. Now the question is it hanging now or not? Let's see. It is hanging here. It's okay. This looks like we are hanging now. That's not good. Shut down, wait, stop. We're waiting here on this join. And this one is waiting on here. Oh, I see. I see. Oh. Oh. Quit is true, but it's waiting in here. Uh-oh. Oh. But why? When we push the quit command, it should have freed here. Huh. Let's see if it's reproducible. Well, let's first check if exit works reliably. Compare. Exit. Let's do it once more. Compare. Exit. Okay, that's good. Then let's do the other one, the close window. Yeah, so this one doesn't work. It gets stuck here. Here. Why? Prepare shutdown wait is calling stop. It enqueues this quit command. And the quit command should work. Quit true. Quit true. Why is this? Why is it here? Because the command is just queued. No. Come on. Yeah. We no longer call updates, right? Or do we? What is main thread doing? Main thread is waiting. The main thread is waiting. So the main thread won't get past this here anyway. I see. Stop. Join. Thread join. So yeah, so callback queue size has 1 inside. Callback queue is 1. Quit is true. Why did it get in here though? Couldn't it have gone in here? Quit is already true. But it was probably being worked on later. Wait DQ. Oh. Can we say want to quit? Don't quit. Yeah. Quit. Yeah. Quit. Quit. Okay, I see there's 2 problems. It's 2 problems. If quit is not being evaluated right away, you know, command quit. before the quit has worked because the work was being executed within this thread here. But now it's being executed on a different thread, so it can reach this again before the quit is actually set. That's a problem. Yeah, that's one of the problems. Oh boy. Yeah, so this is wrong now. Huh. The other problem is that when we stop here and we join the thread and just wait for it to quit, we will never call the update, so this one will never reach 0. That's the second problem. Oh boy. So this stop here would need to call update as well. Shit. Have to. Quit. Okay, where do we do the quit? Stop. Here. Maybe maybe we need to set quit already here. And the command quit here is just to yeah, command Q and Q. Owner Q. So what we can do is we simply say quit equals true. And then we just pass a command pointer. But then we should probably make this atomic bool. And this as well. So we set quit to true already here. Now here we pass a null pointer. That's not quite right. Shouldn't be null. No, we no longer need to do this here. Essentially. So we just have a dummy work, essentially. Dummy work. We set quit here. This will wake the queue. Wakes up the queue. Okay, and then here in thread join, we essentially would need to update. Need to keep updating. Huh. Update callbacks. Update callbacks. Update callbacks. Update callbacks. Yeah, we would need to call this guy here, but oof. Call it from here. It's not so nice. Quit and signal quit and wake up the queue. Okay, but so this problem should be fixed. But what about this one? This is still a problem. Thread join. We cannot join because this thread will never exit as it stands right now when this one cannot reach 0. And it cannot reach 0 when we don't call this one here. So we would need to call update here, but that's, Stop. Wait, now we have to. Mwah. Quit. Wait. This is hard. Oh my gosh. This is a real problem. But there must be a solution. And hopefully a somewhat elegant, but we don't want to call update here in the stop. That would be weird. So we have to somehow keep this callback queue 0. Well, there's no guarantee, because when this guy is still working on things, then this guy can be filled. Actually, yeah, it can because of this here. Yeah. Shit. How do we fix that? We need to join. We need to join because we need to finish this in the stop. We cannot afford another update. Huh. Huh. Oof. That's right. And Q, stop. Well, it looks like we have to call update callbacks there. That's not nice. Command Q. Start, stop. Maybe we should add some. Start, stop, is busy, is quitting. And Q, and Q, and Q. And Q. Try DQ. Yeah, so basically all functions in here are meant to be called from a single thread. All public functions are meant to be called from one thread only. Yeah. From a single thread only. Okay, then let's go to the stop function. Let's put here curly braces. And then we say while m threads, while so while m thread joinable, we do std threads sleep, or this thread sleep for do we call this anywhere else already? No. Sleep for cd chrono milliseconds. Let's do 10 milliseconds. So while it's joinable, we do update callbacks. Is busy. Still busy. Yeah. Why do we leave this here? It's busy. So while thread is joinable, we update callbacks. I don't know if we still need this here. Probably not. Update callbacks. Quit. Update callbacks. Join. Okay, but this could work now. No. Let's see. It's quite complicated. Let's see. Okay, so the goal is that if we press X, the application will shut down after all the commands are done. So press X now. It's still running. The UI is already gone, and it should quit after some seconds. No? No. Where's it hanging? Put a breakpoint in here. Let's see. Okay, so this is empty. The callback queue size is 0. Okay, where's it hanging then? I don't see where this is hanging. Busy is false, so the thread has shut down, but the thread is still joinable because we didn't call join, I guess. Threads. So we have join, detach, swap. We probably need to, no. Do we need to call detach then? Maybe. Update callbacks. Update callback. Yeah, maybe. Yeah. China bar. Yeah, we probably need to detach always. Yeah. So we probably put a detach here. And then while is busy. Update callbacks. Then here we remove this. Let me say here assert is busy. Okay, and if wait, then we wait while is busy. We update callback sleep for this amount. Yeah. And when it's no longer busy, then we know we are done. Yeah. Busy wait because needs to call update. Okay, let's try this. This might work now. Jesus Christ. Multi-threading is hard. Absolutely. Absolutely. Okay, so we compare, press X. It still works and works and works and it's done. Whoa, Jesus Christ. Okay, so this works now. Let's test the other way. Compare, file, exit, and that has the exit is scheduled and it exits. Okay, so it will always finish all the work first and then it will shut down so that like all the pending tasks are being completed before it shuts down gracefully, which I think is reasonable for now. Yeah. Okay, cool. Let's try one more time. X. Done. Okay, cool. Yeah. That is quite a lot of stuff changed. But if it works, right? Okay, so let's test once more that that the async operations are good. Yeah. All right. Yeah, this seems to work. Yeah, good. Good. Yeah. Yeah. Okay, cool. This works. Yeah, shutdown is a little bit slow. Okay, let's go to release. Let's test it in release. So we can do these two. Compare. That was really fast. Jesus. Okay, the processing is super fast now. It's very nice. Really, really nice. So if we click here and then here, and the quit is good. Very nice. Okay, cool. Yeah. Okay. Now, do we actually need this here? I think we can also simply do auto command, and then we do command work equals this. We do this, return null pointer, enqueue, std move. Then we can remove this guy here. Okay, then let's delete all this here. Also, how about we put the busy stop. How about we put the busy here? Oh no. We put the busy here. Okay, and down here is busy false. Okay, I think this looks pretty okay. Logic is quite a bit more complicated than previously, but it's fast. That's all that matters, right? Okay, so okay, can we simplify this here maybe more? Command wrapper. Command wrapper. Maybe we could use cd tuple. std wrapper objects. Is there something like this? Reference wrapper. Reference wrapper. Private T. Yeah, but we need to be owner. Is there some other functional? I don't know. Essentially, it needs to have this unique pointer here. Needs to own it. Yeah. Okay. Then there's one more thing. Thread pool. Where is it? Thread pools. Thread pools. Thread pools. um thread pools. Yeah. Okay. Thread pool. Reset num threads. Reset num threads. Reset. Okay, how about we create runner. Thread pool. Let's thread pool. In the work queue, how about we create a constructor where we pass the thread pool. Then we put here thread pool. Work queue. Thread pool. And in here we call thread pool this, done. Okay. I used for command work. Let's put this thread here. Used for queue. Used for dequeuing commands. For working on commands to work. Used to dequeue commands. Okay. Okay, and then the runner, we do the same thing. Runner, we pass the thread pool. So these things don't own the thread pools, but we can pass. So in theory, we could also pass a thread pool that both systems share. Actually, maybe that would be desirable, have just one thread pool that all the systems share. Yeah. Maybe that would make a lot of sense, yeah. Maybe. Okay, so we pass this thread pool here. Ah, hold on. It's deleted. Oof. Right. We don't have a runner instance. It's not a problem. We can say static void set thread pool. There we go. Set thread pool, and then we put a static thread pool here. It needs to be a pointer. And then we put it here. Runner, thread pool. Then let's set this function here. There we go. And we do as thread pool equals. Let's do it like this. Thread pool, thread pool, thread pool. Okay, then we go to thread pool. we expect to only set it once. So we put an assert thread pool equals null pointer, and this one is not null pointer. Then so we have a bunch of calls here. Thread pool. Here. No. Here. This one. So we replace this one here, this, with this. There we go. Okay. Okay, and then we I think we can greatly simplify and improve the performance by just having one thread pool for both the runner and the work queue. They both use a thread pool. The same thread pool. Yeah, I think so. Because we don't care what work is being done. If it's work for the queue or work for some command, as long as work is getting done, it's advancing, right? So yeah, I think that's the simplest. It's maybe also more efficient than if we split it up into multiple thread pools. Okay, then we go to where do we create the work queue? I think it's part of ImGUI app. Yeah, it's here. Work queue. Init starts. Work queue init. Right, so we need to where is this being created? Here. Oof. Command line options. Main. where do we open the GUI? Here, GUI run. GUI run. Okay, how about we put a static BS thread pool here. G thread pool. And then here we set runner set thread pool to this one. Unassemblize runner. And then here on run, we pass also the thread pool. G options, G thread pool. We pass here. BS thread pool. Thread pool. Class. Do namespace. Namespace. BS. Class. Thread pool. We also need it here. Pass it here. Why does it not have a run function? It does. Why is it down here? Make unique thread pool. Okay. std make unique imgui app thread pool. Okay, so we pass the thread pool to the runner and to the work queue now, right? So there should be a constructor here, and here we set work queue, which needs to take the BS thread pool thread pool. Thread pool, thread pool. There we go. Then let's also do a namespace BS class thread pool. Okay, let's see if that compiles. It does. Okay, then we need to go to our main CPP. And then here we say we go to thread pools. So we go total cores. Let's do total cores. Or it's called thread count. Those so if thread count is larger than 2, thread count minus equal to now we do g thread pool reset thread count. Actually, hold on. UI and work here. Actually, it should be GUI options GUI. we should do the following. If options GUI, then if if thread count is bigger than 1, then -1. And otherwise, no, not otherwise. Here, if thread count bigger than 1, -1. Actually, we can do hardware concurrency. Hardware concurrency. So this is main thread. Work queue threads. Put this here. UI. Can this return 0? Hardware concurrency. Should be considered only a hint. Return 0. Oof. Oof. Oh, that's not good. Actually, hold on. This is not safe what we're doing right now, because if we launch, oof. We cannot use the same thread pool, because otherwise we would launch threads from the thread pool, from a thread of a thread pool. That's not right, because a work queue is putting work on threads from the thread pool, but the work invokes a runner, and the runner will eventually also invoke threads from a pool. So that's not right. No, we can't do this. Oof. Okay, let's call this runner thread pool. work queue thread pool. So we have thread count, city max, so this is runner thread pool. Work queue thread pool. Then we say thread count, work queue thread count equals thread count divided by 4. Probably use this logic here. 4 max. Wait, what is 1 divided by 4 is 1, no? Oh. 1 divided by 4. Oh, it's actually 0. Oof. Okay, so I do std max. One. We do runner. This minus 2. Actually, if this let's do it differently. If GUI else so like this. And here we have work queue thread count 0 and runner thread count is thread count -1. Let's initialize this with zero, if that works. Create threads, num threads, determine thread count. Determine thread count. I think this should be done differently. We should put std unique pointer. Then we say std max okay, then we say if is larger than 0, then here main function. Get Okay, so if work queue thread count is bigger than 0, then we do runner work queue thread pool std make unique bs thread pool okay. Then we have an assert runner thread count is larger than 0. Okay, -2 hold on. Thread count -2 because -2 for main thread and work queue. -1 for main threads. Okay, this should work. I wonder if we should also pass null pointer here. Pointer run. We should pass a reference here. Asserts. It's not null pointer. What's up with this GUI error? Why is this not set anywhere? Here's a set. Okay. Good, so this should work now. Actually, it might not compile because of includes. Should put this here. Okay, let's remove these includes here. Interestingly, it still compiles. It's odd to me because how does it know this then? Because in the runner we have it included. Okay, what happens if we remove this here? Okay, now we get some errors. Okay, so let's put name BS. Okay. Okay, that works. Can we remove this threads? This thread thingy here. Yes. Can we actually remove this? Yeah, I don't think so. No, we can't. Okay, good. Then that would settle it. Good. How about we put that in another function? So we have here pass options. Let's create a init void initialize thread pools. Then we take this guy, put it in here. Put it up here. So we have thread count. Zero, zero, larger than 0. G option square. Let's add what is this? Bool GUI. G options GUI. Okay. Then let's put a breakpoint here and see how that goes. So GUI is true. Thread count is 16. Let's start with debugging. Okay, step in here. There we go. Okay, so thread count 16. So 4 threads for the work queue and 10 threads for the runner. Maybe it would make sense more threads for the runner and less for the work queue. 4. Hard to say. 4, 10, 4. I think it's okay. Good, so we have here, it's bigger than 0, so we allocate this. It would be nice if we could give those threads names as well, but that doesn't seem to be supported here. There are no names for the thread pool. Okay, so we have 10. How about we add a debug here? Define override log q thread count 1. Define runner thread count 1. We say if defined q thread count and if overrides thread counts for testing. Yeah, we need a way to set it to 1 so that we can easily debug. If we have multiple threads running the same code, it would be hard to debug things. So that's why we need it this way. So whenever we debug something the work queue does or the runner does, and we don't want multiple threads executing it, then we need to set this to 1. Okay, let's comment this out. Okay, let's give it a try again. So it's 4 and it's 10. So we should now have, let's see, yeah, we have 14 worker threads now here. Yeah. Okay. And things should work just fine. Okay. So how about we remove we delete now this file here. Where is it? This this one. And then we also remove it here. Okay, so let's see how fast things are now. Oof, that's actually very slow. We're still in debug. Let's go to release. Okay, that was very fast. Okay, let's let's make a performance comparison. Let's open pics. Okay, so first we make let's close this instance here. Okay. Okay, so first first we capture the optimize, the multi-threading one. Let's go. Ah, shit. We need to restart it as administrator. All right, so start capture and action. Okay, done. Stop. Okay, so that's number one. Now we close this and then we go stash. Then we compile. Okay, and then we run this. And then we create a new captcha. Attach, start, and voila. Done. Good. So let's compare these, how long these took. So we need to find the start of the action. So this is the main function. Here is here it is load exe. Load exe. Okay, looks like here's the first. Yeah. Okay, so we start here. And until where does it go? Okay, up to here, disassemble. Probably up here. Yeah. Okay, it looks like it took 680 milliseconds altogether. If we can trust this. 680 milliseconds. Yeah. Okay, how long did it take here? Okay. PDB reader, read symbols. Hold on. PDB, where do we read the PDB here? Here, PDB, okay. Good, so we start with PDB, reading here. And it's basically all in this one chunk. Up to here. Up to here. Yeah. Right, disassemble function. Yeah. okay, so we went from 2.68 seconds, 2680 seconds, to 680 milliseconds. So we saved 2 seconds. Yeah, that's 3, 4, 5 times faster, roundabout. Yeah. Yeah, it's significantly faster, but it's also significantly more complicated to look at it in the capture and then debugging. Yeah. Yeah. I hope it's worth it. Yeah. Okay, good. So certainly there's a measurable gain, so that's good. But yeah, the changes are quite significant. I think we can revert this change here. I think this pointer is fine. Revert this. Okay, good. Then next change, next session, we will clean up this change and submit it. And hopefully it will be all fine. Yeah, there's always a danger of crashes with multi-threading. So I hope that we don't run into any bad crashes. But so far seems to be fine. Yeah. Yeah. Good. Then I will take a break here. It has been 4 hours 25. Oof. That's a long session. Good. I will take a break here. Next session we will test a little bit more, clean up the change, submit it, and then move on to the next thing. Yeah. All right. I hope you enjoyed. I wish you a great day or night. Until next time. Goodbye.